environmental cycles. Nitrogen. Nitrogen is present in any form of life, being an essential component of proteins, genetic material, chlorophyll, and other key organic molecules. The Earth's atmosphere is 78% nitrogen gas, but most plants and animals cannot absorb nitrogen directly from the air as they do with carbon dioxide and oxygen. Instead, they must wait for it to be fixed, that is, pulled from the air and bonded to hydrogen or oxygen to form inorganic compounds, mainly ammonium and nitrate. This process is called fixation, and soil microbes are the major natural suppliers of new biologically available nitrogen, fixing around 150 million metric tons of nitrogen per year. Lightning also indirectly transforms 3 million metric tons of atmospheric nitrogen into nitrates, which rain onto soil. While atmospheric nitrogen is important, much previously fixed nitrogen is already cycling among living and non-living elements of the Earth's ecosystems, hence calling into play other processes: ammonification, nitrification, assimilation, and denitrification. Ammonification occurs when bacteria and fungi convert rotted plants and animal remains containing organic nitrogen into ammonium. Nitrification is the conversion, performed primarily by soil-living bacteria, of ammonia, which is toxic to plants, to nitrites, and then nitrates. Assimilation is the absorption of nitrogen by plants and animals. Plants absorb nitrate or nitrite from the soil via their roots and grow plant tissue, which is then consumed by herbivores, who are then eaten by carnivores, and so on. Finally, denitrification is the reduction by soil bacteria of nitrates into nitrogen gas, which goes back to the atmosphere, completing the nitrogen cycle. The fixed nitrogen that exceeds demand is conveyed into the oceans, where it is either absorbed by other organisms, becomes sediment, or evaporates back into the atmosphere. Fixation and denitrification balance each other, and through such interplay, control the input and output of nitrogen in ecosystems. However, human activities have accelerated the global emissions of gases containing traces of nitrogen, and are now responsible for 40% of nitrous oxide, 80% of nitric oxide, and 70% of ammonia releases into the atmosphere. Industrial fixation of nitrogen for use as fertilizer totals approximately 80 million metric tons of nitrogen every year. An additional 40 million metric tons from leguminous crops, such as soybeans, peas, and alfalfa, make agriculture by far the largest contributor of extra nitrogen to the global cycle. Livestock's contribution to nitrogen increases is closely linked to agriculture, and not just because manure contains organic nitrogen, but especially because animal feeding requires more agricultural space. The burning of fossil fuels such as coal and oil releases previously fixed nitrogen from long-term storage in geological formations back to the atmosphere in the form of nitric oxide. Transportation combustion emits more than 10 million metric tons of nitrogen per year. Combustion processes in factories and power plants produce another 6 million metric tons. Electricity and heat consumption linked to urban development contribute with an additional 4 million metric tons every year. Land clearing and biomass burning as an alternative source of energy emit 10 million metric tons. Finally, on-site sewage facilities such as septic tanks can also release large amounts of nitrogen into the environment. Some regions of the Earth receive little direct input of human-generated nitrogen. Yet, it is a global cycle, and the increase in fixed nitrogen falling to the ground as wet or dry deposition is readily detectable anywhere on the planet. Serious environmental consequences are already visible. It is urgent that drastic national and international policies address the nitrogen issue in an attempt to contain its future impacts.